This conference will now be recorded.
Good afternoon, everyone. I am Rajni Jain on behalf of agricultureinformation.com. I'd like to welcome you all to this online meeting. Please take a moment to review the guidelines for this online meeting posted in the chat window. I now request the moderator, Mr. Lakshmipati, to introduce the speaker and start the meeting. Thank you.
Thank you, Ms. Rajini. Good afternoon, everyone. I am Lakshmipati. I'll be moderating this meeting. Agricultureinformation.com likes to welcome to this meeting Dr. Venkata Sameer Kumar, the professor at PJTSAU University, Hyderabad, Telangana. Dr. Venkata Sameer Kumar will be speaking on the topic Enhancing Pulses Productivity, Challenges and Opportunities. I now request the speaker to begin.
Thank you, Lakshmipati Garu. Good afternoon, everybody.
Thank you, sir. Your camera is off now. Can you please come on the camera if you have no networking issues? Yes, now we are all visible.
Yeah. Thank you, Lakshmipati Garu. Good afternoon, everybody. So
Welcome,
thank you, the agricultureinformation.com for giving me an opportunity to talk on the pulses. And basically, if you look at the pulses, there are a number of issues in the global agriculture. So issues like, say, for example, hidden hunger. So the quality nutrition, which is available to the poor and underprivileged sections of the society, as well as protein energy malnutrition, which is prevailing, which has resulted into stunting, wasting, and underweight of the developing children of below 5 years of age, as well as the anemic population, particularly in the pregnant women, particularly in Asia and Africa. So these are the major issues which have to be addressed. Keeping this all into consideration, the United Nations has launched the Zero Hunger Challenge program, and which envisages that there are 15 sustainable development goals, and among the 15 sustainable developmental goals, the agricultural developmental goals, particularly, there should be no wastage of the food, and all the cropping systems should be sustainable, and farmers should double their income, as well as eradication of malnutrition at all levels. So these are the 5 basic sustainable goals. In that particular context, enhancing the productivity of pulses assumes significance in this particular context. And if you look at the Indian projections, so say for example in 2021 we have nearly 25.5 million tons of pulses produced, and it is a significant hike if you compare the pulses which are produced in 2005 and 6, which is around 13 billion tons. And having said that, if you look at the population, 1.21 billion population of the India, and which is expected to rise by 1.7 billions by 2050, and at present the per capita availability of the pulse or protein is 37 grams per capita per day, as well as the ICMR recommendation is 52 grams. So there is a need to produce 32 million tons of the pulses for the requirement of Indian population by the end of 2050. And if you look at the pulses, they're climate smart. We say that nowadays the virtual water or water footprint, all these terminologies have come into the force because of the importance of the water. So the consumption of water per kg of different proteinaceous foods, say for example, dal requires 1,250 liters, whereas chicken 4,000 liters more than, and mutton more than 5,000 liters, and beef more than 30,000 liters. So they're climate smart, and they require very. And we often say that the climate change, the issue of major concern, and there are a number of factors which are contributing for the climate change. Say, for example, the industry sector is the one which has nearly 30% of the climate change effects are because of that. And agriculture also contributes nearly 25% towards this climate change ill effects, and that is the building up of the higher carbon dioxide in the atmosphere, as well as the enhanced levels of chlorofluorocarbons in the atmosphere, and emission of greenhouse gases, all those things. But in the agriculture sector, the majority of the consumption is towards the mining of the fertilizers from the underground, which contributes. So through mining, we are producing nearly 87 million tons per annum. So this is the mining of the fertilizers, which is nearly 80 to 7 million tons. But if you introduce the pulse into the system, into the cropping system, they have the inherent ability to fix the nitrogen, atmospheric nitrogen, and they can fix in the soil. So if you see the exactly nearly 50% or more than 50% of the nitrogen which is built into the soil by the pulse crops in different continents or countries is roughly around 47%, and this is worth nearly 50 billion US dollars. So that is the significant contribution of the pulses to the sustainable agriculture. So coming to the pulses, nearly 50% of the pulse is occupied by the chickpea in the country. And earlier the chickpea was majorly grown in North India, but over a period of time, it has moved to southern Indian states like Telangana, Karnataka, Andhra Pradesh, as well as parts of Maharashtra like that. So it is followed by nearly 16% by the pigeon pea, and the chickpea is cultivated in nearly 10 million hectares. That is 100 lakh hectares in the country, and pigeon pea nearly 50 lakh hectares, and mung bean, urdu bean, lentil, peas, rajmas, all this contributes to the cultivation of pulses in the country. And the major states like Andhra Pradesh, Bihar, Maharashtra, Madhya Pradesh, Karnataka, Rajasthan, Uttar Pradesh, Tamil Nadu, these are the major pulse growing states in the country. And if you look at the Pulse Research Network in the country, Indian Institute of Pulse Research, located in Kanpur, Uttar Pradesh, under the Indian Council of Agriculture Research, as well as it is coordinated by different state agriculture universities in the respective states, and n number of AACRP centers, we say the All India Coordinated Research Centers, AACRP and chickpeas located in IAPR Kanpur, and AACRP pigeon peas located in IAPR Kanpur, and AACRP and arid legumes is located in Jodhpur, Rajasthan, and AACRP and Mullarp is located in IAPR Kanpur. So this Mullarp means nothing but mung bean, urdu bean, lentil, lathras, rajmas and peas. And apart from that, we do have the international organization, one of the 15 CG centers in the country, that is ICRISAT, located in Hyderabad. It looks after the pulses improvement, particularly for the chickpea and pigeon pea. So these are the pulse research network in the country. And even though there is a tremendous vast pulse network in the country, there are a number of research and developmental issues in this particular crop. So for example, the yield gap. So we at experimental research stations will record nearly 3 to 5 tons per hectare of the yield of these pulses. But if you look at the yield which is realized by the farming community, is not more than 800 to 900 kgs per hectare. So if you look at the stats or data for the last 7 to 8 decades, there is a significant improvement of the yields or productivity of rice, maize and wheat in the country. But if you look at the pulses, during 1950 to 1960, the productivity or yield per hectare was not more than 400 kgs per hectare. But now in the year 2019-20, the yield per hectare is not more than 800 kgs per hectare. What I mean to say is we could double the yield of the pulses over a period of 7 to 8 decades. But if you look at the rice, or if you look at the maize, or if you look at the wheat, the yields are 3 to 4 times, or in some cases, in case of maize, 5 times more yield was achieved because of so many factors. And this part, even the yield gap, what I mean to say, the potential yield of the released varieties is 3 to 5 tons per hectare in case of pigeon pea, chickpea, green gram, black gram, like that. But the farmers are not harnessing not more than 800 to 900 kgs per hectare. So there is tremendous yield gap, and there are a number of issues why this yield gap is happening. In case of pulses, the seed replacement rate is very low. And if you look at a commercial crop like cotton or commercial crop like maize, the seed replacement rate is nearly 95 to 100%. But in case of pulses, the seed replacement rate is not more than 15 to 20% in the country. And majority of the pulses are cultivated under rainfed agriculture, and integrated crop management technologies are also not followed in case of pulses. And apart from that, a number of biotic and abiotic constraints, biotic particularly the pests and diseases. In case of pigeon pea and chickpea, the helicoverpa, deadly pest, till now we do not have answer for that. And apart from that, being a rainfed crops, they are subjected for vagaries of the climatic change across the different agroecologies of the country. And the market price is also not remunerative in many of the pulses, except the green gram and black gram, which have or green gram even touches 70 rupees per kg. But if you look at the other pulses, particularly the red gram or PJNP or chickpea, the market prices fluctuates. So this is also one of the major issue. And commercial perspective, say for example, in a country like India, if you look at Hyderabad, nearly 450 private companies are there. Similarly, across the country, nearly there are 500 to 550 private companies, but they do not have the perspective for the multiplication of the pulses varieties. And even the research thrust by the public and private sector towards pulses is very less compared to the other cereal crops like rice, maize and wheat. So these are the main major R&D issues and challenges. And apart from that, there are a number of constraints in pulses production, like pulses are mainly grown in marginal lands with low fertility condition, and the technologies, say for example, inadequate availability of labor saving technologies, varieties suitable for machine harvesting or herbicide resistance for pulses. Say for example, if you take a crop like rice or maize, a number of herbicides are available. Similarly, the rice farming is completely mechanized. So such mechanized technologies are not available in pulses. And apart from that, pulses are also prone to the damage by the storage pests. So these are some of the constraints. And apart from these constraints, so keeping in view of these constraints and research and developmental issues in these particular crops, so a number of interventions were proposed by the central government as well as the state governments of the Department of Agriculture, and particularly in the particular context, bringing a pulses revolution to eastern India. Particularly in the eastern India, a lot of rice is grown. Rice fallow pulses, there is a tremendous area of nearly 10 million hectares which can be tapped for rice fallow by pulse. So basically the thing is, if we can introduce a pulse proceeding rice, definitely it will lead to enhancement of the soil sustainability and enhancing the farmer's income. So that is also one of the area which was focused in the last a decade or so, and bringing additional area under the pulses through intercropping and sequential cropping. Say for example, nowadays we are seeing a lot of monocropping of maize as well as cotton. So introduction of the pulses are such a crop. Say for example, green gram, black gram or soybean or red gram, they can be intercropped with any rainfed crop. So that is the tremendous advantage. And even if you take the post rainy season or rabi season, chickpea, a pulse crop which is raised under residual mature, it can be intercropped with sunflower, it can be intercropped with soybean, it can be intercropped with sorghum, or it can be intercropped with mustard, like that. So those intercropping technologies are to be popularized. And apart from that, enhancing the pulses cultivation in peninsular India, which is monocropping dominated by maize and cotton, this has to be this is also looked at for the proposed intervention. Knowledge empowerment of stakeholders, like as I said, the diffusion of integrated crop management technologies is very less in this particular crop compared to other crops like rice and wheat and maize. So knowledge empowerment of the farming community, knowledge empowerment of the Department of Agriculture, capacitating the particularly the women farming community was also focused. And in the recent past, we know that the hybrid technology in crops like cotton, sorghum as well as maize has led to tremendous enhancements of productivity or increase in the yield. The expansion of the PJNP hybrids recently, for the last 1 to 2 decades, the ICRISAT has come up with a number of CGMS, cytoplasmic and genetic male sterility based hybrids. So expanding PJNP hybrid production is also one of the proposed intervention in this direction. And the proposed interventions with available technologies, whatever the technologies available, are improving the access of the farmers to seed. Basically, I said that the seed replacement rate is very less, and the formal and informal seed systems which are available in the country are integrated in an efficient manner. And for the last maybe 5 to 6 years, we could achieve the seed replacement rate by nearly 30% in case of pulses. That is because of the integration of the formal and informal seed system, as well as integrated nutrient management was also touched by soil test based fertilizer application and promotion of ridge and furrow method of planting, particularly under rainfed agriculture. It saves water, and in the recent past we are seeing the climate change. Though during the rainy season, the quantum and distribution of rainfall, in some years we are getting only 50% of the rainfall, and the quantum of rainfall, the number of rainy days were also decreased drastically. So promotion of such drought mitigation strategies like ridge and furrow method of planting have boosted the yields in case of pulses, and wherever there is possibility, promotion of micro irrigation and integrated pest management to address the issues and the huge cost involved in the management of helicorp and maruca and other pests which are attacking the pulse crop. Enhancing the mechanization, particularly in red gram and chickpea, the mechanical harvesting has been promoted by modifying the by designing and breeding and development of high yielding varieties, by having more height from the ground level so that mechanization is possible. And apart from that, policy support price, enhancing the minimum support price and other issues were taken into considerations for the enhancements of the yield of the pulses. And majority of the research programs and in the scientific community or in the breeding terminology, we can say that the genetic enhancement is very narrow in the pulse crops. And say for example, in case of pulse crops like chickpea and PJTSAU, green gram and black gram, we do have the germplasm lines nearly 13,000 lines in PJTSAU and 15,000 lines in chickpea. Similarly, 7,000 lines in green gram, like that, which are conserved in the gene banks. But only few proportion, not more than 1 to 2% of these available germplasm lines are utilized in the breeding programs. So pre-breeding efforts as well as genetic enhancement of these particular crops by introducing more and more germplasm lines into the breeding programs was done, and the efforts were also under progress for the pod borer resistance transgenic chickpea and PJTSAU, and as well as development of hybrids in PJTSAU and enhancing resources efficiency in pulses and rice fallows. And genomics is one aspect which has been come up tremendously well in the recent past, because all the genomes of, say for example, PJTSAU, chickpea and other pulses are sequenced now, and now the marker-assisted backcrossing, marker-assisted breeding, the breeding programs are available to the breeding community. And say for example, recently Indian Agricultural Research Institute located in New Delhi, Pusa, they have released 2 chickpea varieties in the year 2020 based on the marker-assisted breeding, and this genomics will help certainly for the fast-track release of the varieties. Say for example, conventionally a breeder releases a variety which takes nearly 13 to 15 years. But if we can introduce the marker-assisted breeding by the genomic-assisted breeding technologies, we can reduce the time of release of the variety to less than half. Nearly within a span of 6 to 7 years, we can release varieties, and because of the genome sequencing of these crops are available, and those efforts were successful by the breeding community across the country in all the crops for different agroecologies. Say for example, we have diversified agroecologies. Say if I can quote one example. Say in case of Telangana, they say for example there are 3 zones like northern Telangana, central Telangana, southern Telangana zones. So northern Telangana receives nearly 1,000 to 1,200 millimeters of rainfall, and central Telangana 800 to 900 millimeters, and southern Telangana receives not more than 550 to 650 millimeters of rainfall. So similar situation prevails across the country and across the states, and we cannot blanketly recommend a single variety for all the agroecologies. And we do have dominance of light soils or red soils nearly to 60 to 70% in one state, and remaining is occupied by black soils, like that. So for the different soil types also we cannot recommend a single variety. Again, there are ecologies like irrigated ecology as well as rain-fed ecology. So we have to breed and develop agroecological micro niche specific varieties so that farmers will have better yielding ability of those varieties in their particular agroecologies. So this research focuses on the development of high yielding varieties for the respective agroecologies by using the genomic assisted breeding interventions have picked up a lot, and in the coming maybe 1 or 2 decades we'll have a wide spectrum as well as broad spectrum of varieties in pulses which can boost the yields. And just I will be focusing on some of the of course I told about the seed system. See, these are some of the areas. Say, for example, in case of chickpea, there are no herbicide tolerant varieties. And say for example, in case of rice, there are 10 to 12 herbicides are available. So the efforts, breeding efforts are under progress to identify. Say for example, this is the herbicide treated plot, and you can see the variability. Some chickpea lines completely died because of the herbicide, but some chickpea lines have shown the resistance. So the breeding programs are in progress for the development of herbicide tolerant varieties in chickpea. For example, in case of PJNP, we do have herbicides because PJNP can tolerate the herbicide. Nowadays, because of the cost involved in the labor and the increase in cost of cultivation, non-availability of labor focuses on the development of the chickpea varieties suitable for herbicide resistance. Similarly, you can see this is the chickpea genotype, which has ground clearance of more than 60 millimeters from the ground. So this is amenable for the harvesting by the combiners. So these are the efforts which took place for the last 8 to 10 years, and now these are under the farming condition, so they are harvesting by using the machines. Similarly, the PJNP hybrids are also picking up with the reduced maturity duration for the different agroecologies. And apart from that, enhanced phosphorus application efficiency is one of the area for majority of the pulses, and exploitation of wild species and transgenics for the insect resistance and protein enhancement. For example, all the pulses will have the protein content of 20 to 22%, all the released varieties which are available in the market. But if you see the germplasm, there is a range even up to 30 to 35% of the protein. So efforts are under progress to have varieties with high protein content, nearly 25% protein content. These things are also under progress. And major research breakthroughs, if you look at in case of pulses, for example, the green gram, the green gram duration has been reduced to 55 days now from 75 days. So in North India, the summer moong has picked up a lot. Similarly, the seed size of Kabuli increased from 35 to 68 grams. So earlier we used to import the Kabuli from Afghanistan and Pakistan, but nowadays we do have our own Kabuli varieties which are nearly 70 grams for the 100 seed weight. Similarly, the yellow mosaic virus resistant varieties are available, as well as high input responsive wilt resistant varieties are also available in chickpea, and early maturing varieties are also developed in case of PJNP, and green seeded variety developed in case of field pea. Like this, these are the major breakthroughs in case of pulses. And this is one example, which is say for example, if you look back to 1960s and 70s, the chickpea was cultivated in northern India, nearly 50 lakh hectares. But if you look at the current stats, it is not more than 7 lakh hectares. So this is the significant reduction. But at the same time, in the central and southern India, like Maharashtra, Karnataka, Andhra Pradesh, Telangana, and Karnataka, the chickpea area has increased from 2 million hectares to 6 million hectares. So this is because of, in case of North India, there will be more winters and prolonged winter periods. But in case of southern India, the winter is very less compared to the North India. So this has become, this is possible because of the building and development of early matured varieties, as well as coupled with the high yield in case of chickpea. So this is one classical example of shift of chickpea from northern India to southern India due to development of high yielding early duration varieties. And these are the hybrids. The universities from Odisha, Maharashtra, as well as the Madhya Pradesh, they have come up with the CGMS hybrids in PJNP. The area is also expanding under the hybrid PJNP. And coming to the biotechnological aspects, these are some of the examples which I quoted earlier. The chickpea genome sequence is available. And the CRISAT has come up with the 3000 chickpea genome sequencing initiative, which is useful for the breeding community. Similarly, the PJNP genome sequencing is also available. I will not touch all the details because this is highly scientific, may not be palatable to some of the listeners. Similarly, the 1000 pulse genome sequencing initiative was taken up at CRISAT. So all this information is available in the public domain. The research community across the country can utilize these research interventions for their breeding programs. Similarly, for the drought, which is a major problem in case of chickpea, the QTL hotspot region has been identified, and this is shared across the country. So the breeders are now utilizing this particular information for the breeding and development of drought-tolerant varieties in case of chickpea. And similarly, the marker-assisted backcrossing for Fijian wilt and Ascochyta blight. These two are the major diseases of chickpea, and whatever the varieties which are released through conventional breeding are not that much highly resistant for these two diseases. So by using this genomics assisted breeding, marker assisted breeding, backcrossing technology, the Fugermint as well as Ascosheta blade resistance has been introgressed and transferred to different cultivars. Similar efforts are in progress, just like BT cotton, the BT PGNP as well as BT chickpea are under progress by Indian Institute of Pulses Research as well as ICRISAT, and we are ready with the varieties. But unfortunately, in our country, for the food crops, the BT food crops are not allowed for cultivation. That's why once we get the clearance, we are ready with the BT PGNP as well as BT chickpea also. And this is the pulse rice fallow. Nearly 11.7 million hectares is available in different states like Tamil Nadu, Andhra Pradesh, Odisha, Karnataka, West Bengal, Assam, Bihar, Jharkhand. So this is also under utilization for the expansion of the area and sustainable intensification of rice cropping system across the country. So there are a number of opportunities in this particular crop for increasing availability of the pulses. Horizontal expansion, the current area of the pulses of all the pulses is 25 million hectares, and there is a chance for expanding by 6 more million hectares. And similarly, the vertical expansion, but in a single field we can take up more number of crops. So that is also a possibility in case of chickpea as well as PGNP. And there are a number of success stories which I was mentioning in my presentation. Say for example, chickpea revolution in Andhra Pradesh, hybrid PGNP, black gum revolution, rice fallows of Andhra Pradesh, summer moonbeam, particularly in the northern India, is one of the success story in this particular crop. And there is a need for dissemination of technologies, and efforts are under progress, like farmer participatory seed production, farmer to farmer extension model, frontline demonstrations, international and national training programs for the scientific community, for capacitating the scientific community as well as the farming community, and a number of farmers days, field days, farmers fairs for the popularization, are getting acquaintance by the farming community of high yielding varieties as well as integrated crop management technologies, and publication of farmers friendly literature in local vernacular languages, and pulse expert system by using different apps is also available now. And the way forward, if you look at the way forward, there is a need for the development of super early varieties which can mature still in early duration compared to the existing duration with high yield, photo and thermo insensitive varieties, climate resilient varieties like that. A number of tools which I touched upon in my presentation. And there is a need for the policy interventions. So like a higher strategic research investment from the government, as well as there was one program like accelerated pulse production program like A3P, which has to be continued, and strengthening of kharif pulse production in the country by reducing shifting area. The government of India has to sustain the incremental increase pulses by providing the appropriate MSP or encouraging MSP to the farming community. And the role of private seed companies should be enhanced, particularly in case of the pulses seed production and dissemination to the farmers. And this is one area. Say for example, we are purchasing every year dal at 100 rupees, or for example in 2016 also we we purchased the PGNP dal, that is the red drum dal, around 200 rupees per kg. So if you look at the dal mills, the centers like Gulbarga, Lapur, or Thandu, or Vikarabad, or Guntur, like that, a number of centers are there with huge investments of crores and crores of rupees. But the PJTSAU, we have prototyped one, the mini dal mill, which has 2 to 3 quintal per hour capacity, and the cost of this particular dal mill is around 6 to 7 lakhs. It runs with 1 HP motor, and the advantage with this is there is a need for institutionalization of these dal mills at the village level, so that farmers can have their own dal for their own consumption purpose, as well as he can get higher profits by making dal at his home or village level and selling in the market. So this is one area we are trying our best to introduce into the farming community by farmer producer organizations, institutionalization and installation of mini dal mills, so that farmers can get the benefits of the higher productivity and higher yields. And this is one area which in India we didn't look up. Say for example, I have taken this example of PGNP here, but as far as value addition is concerned, in case of chickpea, we have tremendous value addition. Chickpea is used for snacks and so many things we know very well. But this is the value addition of PGNP, which is across the globe. Say for example, this is the green PGNPs, which I have purchased in the US market. They are selling around $50. So nothing but the matured during green pulp stage, they have harvested the PGNPs and they have stored in the brain solution. So like that, this is the value addition which I have seen in case of Philippines, Thailand, Bangkok, Vietnam. Like that in PGNP, it is unbelievable. They are preparing milk, they are preparing the coffee, and they are using the PGNPs for the for the sprouted PGNP meal as a feed to the broilers, and even feeding the tilapia fish, and the PNP leaf decoction they are using in the medicinal properties. They have the medicinal properties like anti-cholesterogenic and anti-diabetic, and a number of packaged foods. So this is one area which we can look at under the Indian context, so that there will be, even though we have more production, so there will be more utilization of the produced dal instead of storing in the storage as well as subjecting them to the storage space. So this is one area where there is a tremendous opportunity for the exploitation. I think I'm done with my presentation. So thank you, the organizers, and now I will be very happy to clarify if there are any queries or doubts from the listeners.
Thank you, Dr. Venkata Sameer Kumar, for an interesting and detailed presentation. I now request the participants to ask their questions. We'll also be posting the speaker's contact details in the chat window. Now over to the participants for questions. Any questions, participants? Now, first question will be from Mr. Sudhiranjan Mandal. Yes, Mr. Sudhiranjan Mandal.
Good evening, Dr. Sameer, Venkata Sameer Kumar. Thank you so much for that very interesting presentation on pulses. Actually, I was wondering because of this BT thing, this in food, the dangers of the insect resistant varieties developing even through this transgenic crops like BT cotton has been getting established. So do you feel that again we should do further research on BT pulses?
Yeah, as a researcher, if I look at the research perspective, definitely, as you said, there are a number of ethical issues in BT crops, and at one side, so many people have proved that these ethical issues or ethical concerns, which are which are expressed by different section of the societies, they're baseless, something like that. But at the same time, having said that, there are a number of repercussions, and even, for example, US, it cultivates a lot of BT crops, but in the supermarkets they sell BT separately and non-BT separately, and many of the US people, they are not purchasing the BT, even though they are encouraging the BT cultivation, but their consumption is very less. So, sir, as you rightly said, still we do have very good third generation chemicals for the control of helicoverpa and maruca, and we do have a very good integrated pest management technology available. So if the farmers if they adopt these technologies, and there is no need for BT. So I also vote with you, there is no need for BT, but just I want to acquaint you what is the latest position on the BT technology, like that I have highlighted. But if the farmer can adopt the available integrated pest management technology, IPM we say, as well as a number of chemicals are available to effectively control the pests, there is no need for the BT, sir.
Thank you, sir. Thank you.
Thank you. Next question. Any other question? Any questions, please? Next question would be from where?
Yes, sir. Yes, sir. Thank you, sir.
Siddhappa. Yes, Mr.
Yes, sir. Thank you, sir. Thank you, doctor. Really, this BT, PGNP mutates the genes. Is it so, doctor?
No. See, we have developed successful events, and by integration of BT genes, just like in BT cotton, and we have a number of stabilizer lines. So there is, literally the IIPR or ICTISA didn't report any mutation of other genes. It has successfully integrated into the genome of the cultivated types, and the BT protein expression is up to the desirable level. So there are no adverse side effects as per their reports. Sir.
Thank you, doctor. One more thing,
Yeah.
doctor. In Gulbarga and Tur belt, as it is a Tur belt, they use extensively a lot of pesticides. So really it affects the nutrients and also protein content in the pigeon pea?
No. See, basically the thing is we do have LD50 value. So say for example, the chemicals like tracer or corazine or imamectin benzoate, they usually the pigeon pea crop sown during the June or July, and it flowers during October 3rd week and 4th week, and it will be there in the maturity up to December. So usually the farmer takes up sowing from October 3rd week or 4th week to up to November, maximum December 1st fortnight. So he will take 2 or 3 sprays to control the insect, and after that the crop matures, and again it will go to the mill, and it will be coming for the consumption as a dal after nearly 3 months after the spraying of the chemical. So at that time there will be no effect of any chemical for the consumption. So there will be effect in the case of fruits and vegetables when the spraying is done immediately within 1 week we are consuming. That is one thing. Second thing is, as you said, the protein content and the other nutritional aspects which are available in this crop, for that matter in any crop, they are genetical aspects. So by outside application of chemicals, there will be no chance, and literally there will not be. I mean, there will be zero chance of reduction in the nutritional status of protein and others, sir.
Okay, thank you, doctor. Thank you, Lakshmipati, sir.
Yes, sir. Welcome. Next question. Who is interested to ask the next question, please? Any more questions? Okay, no questions forthcoming. And then let me go to the chat window to look for questions there. Okay, no questions also in the chat window. Okay, no questions looks like, and that is all we have for the day. I'd like to thank the speaker, Dr. Venkata Sameer Kumar, on behalf of Agriculture Information, for taking his time to speak with us and with an interesting presentation. I now request the organizer of the meeting, Ms. Rajini Jain, to please close the meeting. Thank you.
Thank you, sir.
Welcome, sir.
Thank you, Mr. Lakshmipati. I like to thank the speaker, Dr. Venkata Sameer Kumar, for taking the time to talk with us. I also like to thank all the participants for their time. The meeting will now be closed.
Thank you very much.
Welcome.
You're welcome, sir.